the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes.
Okay, this is section 1.1, problem number 20 out of the linear algebra textbook. For what value or values of h is the augmented matrix representative of a consistent linear system? And before we begin, I just want to make a note here that whenever we have an augmented matrix, I like to put in that vertical pipe there to let you know which column is the augmented column. The author does not do that. That's totally fine. It's just a little clearer of an indication of what we're working with. To begin this problem, we're going to need to recall a little bit of theory. And that is that we have two augmented matrices, or if we have the augmented matrices of two linear systems being row equivalent, then the original two systems that those augmented matrices are based upon must have the same solutions. That's actually going to come into play in this problem. So we're going to go ahead and row reduce, do a little row operation magic on this here augmented matrix. We'll take a negative, or no, actually we'll take twice row 1. We'll add it to row 2 to become the new row 2. Often you do not need to actually write that out, but it's nice to do that at the beginning of a linear algebra course just so you can follow the mathematics that you're doing. So if I take twice row 1 right here and add it down to row 2, you'll get 2 times 1, which is 2, plus a negative 2, which is 0. You get 2 times h, which is 2h, plus 4, which is 4 plus 2h, if I can fit that in there. And then 2 times a negative 3, which is a negative 6, plus 6, which is 0. And at this point, there's nothing else you really need to do here because this augmented matrix, which I arrived at through elementary row operations, so it's row equivalent to that. These two augmented matrices are row equivalent. So the solution set for the linear system for the first augmented matrix will be the same as the solution set for the linear system for the second augmented matrix. And that second augmented matrix, let me scroll down just a little bit, is letting us know that we have 1x sub 1 plus h times x sub 2 is equal to a negative 3. Actually, to be very honest with you, that row plays no role right now in this question. That's the second row that's critically important. We have a coefficient on x sub 2 of 4 plus 2h, and that is supposed to equal 0. Again, that's because we have this row right here, 0x1 plus 4 plus 2h times x sub 2 is equal to 0. Well, we're asked, when is this going to be consistent? So let's use a little imagination here. If that number right here was non-zero, then we'd have, let's say it was like, for example, if h was 0, so therefore the coefficient there was 4, we'd have 4 times x sub 2 is equal to 0. But that's fine. There's nothing wrong with that because that just tells us that x sub 2 is going to be 0 in that case. That's okay because then if you use that in this right up here, remember h is 0, x sub 2 is 0, so you get that x sub 1 is equal to a negative 3. We have a solution, so it's consistent. And in fact, if you try any non-zero or any value of h which creates a non-zero value right here, you'll run into the same situation where you have x sub 2 will be 0, x sub 1 will be some non-zero, or will be some constant. It doesn't have to be a non-zero value. On the other hand, if that 4 plus 2h was actually equal to 0, that is, if, let's see, h is a negative 2, right? Then we would get the following. On that second equation, we get 0 times x sub 2 is equal to 0, which actually is an identity. That equation is called an identity because 0 times anything is still 0, and that would equal 0. So it is actually still true. We're still okay with that. And in fact, if you go up to the first equation right here, and remember h is negative 2, you get x1 is equal to, because remember, x 2, no, h was equal to, sorry about that, let me reset. We get h is equal to negative 2, right? So minus 2x2 will equal to a negative 3, right? And so that will imply that x1 is equal to a negative 3 plus 2x sub 2. The fact that this first group here, we had 0 times x sub 2 is equal to 0, that means x sub 2 could be any number. X sub 2 is free to be anything we want. And so because of that, when you get to this solution right here, it is still going to be a constant, because once somebody comes in and says, well, I'm going to choose x sub 2 to be 1, then x sub 1 will be negative 3 plus 2 times 1, or negative 1. So no matter what we choose for h here, there is always going to be a solution. And in fact, this is a good point to just kind of note. Maybe I should actually write the result of this, because remember it said for what value or values of h is the augmented matrix representative of a consistent linear system. We'd say the system is consistent for all h in the real number system. And honestly, it's actually for all h, that all scalars h. So it doesn't have to just be in the real number system. It could be in the complex number system. Now, the little aside that I wanted to mention here is, if you take a look at that last equation, this guy right here, okay? And in fact, if we just look at this bottom row of the augmented matrix, the only issue we really would have had, or the only questionable work we would have been faced, is if we had a row 0, 4 plus 2h augmented with something non-zero, let's just say 1, okay? If that were the case, let's just pretend that that was our bottom row there, there would be a major issue if this had turned into 0. If that turns into 0, in other words, if h was a negative 2, we'd have 0x1 plus 0x2 is equal to 1, and that is a contradiction. That tells us that 0 is equal to 1, which is, again, a contradiction. And that's kind of the thing you want to watch out for, at least in these early sections. You want to watch out for those contradictions, because then that makes the system inconsistent.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way, cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Just listen close, don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.